And when we look at these lines here, which is the boundary of the property, we see two pieces of information. The first thing is what? A bearing, right? So we see bearings running all along here. We'll talk about the bearings in the middle, in a little bit. There were 5 different measurements you could get in surveying, right? What were those 5 measurements? Horizontal distance, vertical distance, slope distance, horizontal angle, and vertical angle. So what does this boundary, this bearing represent?
Horizontal distance?
Slope.
What does this bearing represent?
Oh, the bearing.
It's got to be an angle, right? It has a degree to it, so it's got to be horizontal.
Horizontal.
Okay, it's not a vertical, right? Show me with your hand a vertical angle. That's a vertical angle. Show me a horizontal angle, right? So we're looking at it's got to be a horizontal angle and it's represented by a bearing. Okay, so what is this now? Is this an angle? No, it's a distance, and it's one of 3. It's either a slope distance, a horizontal distance, or a vertical. What do you think it is?
Horizontal. Horizontal.
Horizontal distance.
Yes.
It's a horizontal distance. And let me explain why, but somebody called out vertical, so let's look at something here. What do you think that 602.3 is? And what is this 598.4? Another elevation, and what's the 614.9? Probably an elevation, and there's a 621.9 here. What is that? An elevation. These are all elevations. There's no way that this 74 feet could be a vertical distance, because we're looking at a 614 elevation here and a 598 here. What is the change in elevation along this line? About?
It's like
17 feet maybe?
17 feet, yeah.
Right, because this is 598, this is 615, right? So this 74 definitely cannot be a vertical distance. So the question is whether it's a horizontal distance or it's a slope distance. So I want to tell you that anytime you see a distance that's representing a horizontal line, the distance is always a horizontal distance. Okay, and now why is that? Let me draw it over here.
Pretty difficult to represent a slope distance.
Say it again?
Pretty difficult to represent a slope on a...
Difficult, and even something even more. So let's say I have, here's my soil, and here's my point A, and here's my point B, right? And I'm looking from above. Got that? Does that look like an eye to you? An eyeball? I'm looking from above. This is my horizontal distance, right? Right here. This is the H. And this right here is my vertical distance. Let's say I own this property. I could come through with a tractor, a backhoe, whatever, and I could just level this whole thing if I wanted, right? And now the horizontal is here. So the horizontal distance never changes even if you move the soil around, even if you do grading. Have you heard the term grading? Mm-hmm. Grading means moving soil around. Even if I do grading, you know? So in this case, if somebody wants to put a house somewhere, they might actually do some grading and level it off. So the B is still along this line and A is still along this line, and the horizontal distance still stays the same. But the slope distance used to be this, and well, now there's no slope distance. So this is not a good distance to ever use. You always want to use the horizontal distance. Does that make sense? Okay. So the slope of something can change over time if you move soil around, but the horizontal distance is still the same. So that means the distance right here from this point to this point of 74.97 is which distance? Horizontal. Okay. Here there's another 97.89. Here's a 63.21, and here's a 53.70. So those are all horizontal distances. Where? Tell me where north is on this drawing. look at your drawing and look at all those bearings. And I'll put it down a little bit. So let's look at, can we look at this line? Let's call this point A. And this is point B.
Straight up.
And the line going from A to B is northwest. So if I had to draw on the side of your notebook, north, south, east, west, what is north 8330? Which quadrant is it in? Is it in the first quadrant, second, third, or fourth?
Two.
Second.
It's going, I'm going from A to B,
Shouldn't
or
it be
am
the
I
A?
going from B to A? It says north, and then what is this?
West.
West. So it's gotta be in the northwest quadrant. So, and I have a feeling that they are numbered. That's in math, when you have the X and Y axis. So we're just gonna call this the northeast quadrant, northwest, southwest, and southeast. So which quadrant is this in?
Northwest.
Northwest. So where should I draw it? Is it drawn like A, or is it drawn here?
There.
B. Tell me why.
Because
You know that song, tell me why.
because you start at north and then you move to the
Start at north and then you go
83 degrees.
83 degrees, 34, 30. Oops. So in essence then, when you're looking at this line, if we have northwest, are we going from A to B or from B to A? Well, if I'm going from A to B, am I going northwest or am I going southeast?
Southeast.
Southeast, right? If I'm going from B to A, then I'm actually going north. So where's north?
It's,
Just going up. So remember what we did last